5-5 procedure for curve sketching. The procedure we're going to do is we're going to find the domain, which will help us kind of understand what can my x's be, where do I have asymptotes, those type of things. These will kind of be intertwined a bit, the domains and asymptotes. Intercepts, x and y intercepts are always nice landmarks. Symmetry, is it symmetric or not, and where. Intervals of decrease and or increase and decrease, which we know how to do with from the first derivative. Local max and mins, concavity, and points of inflection, and then we'll sketch it. This is just kind of our roadmap to curve sketching. Okay? Any questions? Okay, so we're just going to do, I'll just do one, and like I said, there's 3 more after that. After that, I'm going to pause the video more, and we're going to more do it as a group rather than me just teach it, okay? So example 1, discuss the curve 3x to the 5th minus 5x cubed under the headings A through H. So what it means is the headings I just put up here, A through H. Okay, so we're just going to do all those. So we're going to start with A. What is the domain? Yep, all real numbers. Domain's all reals. There's nothing x can't be. So domain is x is all real numbers. So that means we're going to have no vertical asymptotes, right? If x can be everything, we don't have any issues. Okay. B, intercepts. Okay, my y-intercept is 0. That's 0, 0. Plug 0 in for x, I get 0. How about my x-intercept? How do you get an x-intercept? You make y 0, right? So let's see, we take out an x cubed, and we'd get 3x squared minus 5. So plus or minus root 5. Or 5/3, I mean. Plus or minus root 5/3. Do you guys see in that? So 0 and plus, like add 5, divide the 3, and square root. So our x-intercepts okay, those are our x-intercepts. We okay with that? Okay, C. So symmetry is kind of a, I don't want to say curveball. We actually did symmetry, remember? In our pre-calc book, we talked about f of negative x. Okay, you plug that in, then it is symmetric. So this is how you test for symmetry. So f of negative x, if we put in f of negative x in, and we get the same thing, it'll tell us if it's what it's symmetric by. So we're going to put f of negative x in. So what you're going to ask yourself is, if I put f of negative x in, that's a 5, right? So it's going to be now a negative. Like if I just put negative 1. If I put a 3, that's also going to be negative, which makes a positive. So what would that yield? What does that mean? We got the complete opposite. Yep. But what's it mean it's symmetric by? So on our pre-calc thing, there's 2 definitions. There's an even and an odd, and you're right, it is odd. What does odd mean it's symmetric about? Not the y, because the y would be even. Because if it's symmetric about the y-axis, that means it folds on top of itself. This one doesn't fold on top of itself. It's the origin. So when it's odd and you get the complete opposite, it's symmetric about the origin. I think in your book, I'll have to look at the example, but I think in your book it restates that definition. If not, we'll go back to it. Because you look at me like you forgot that a lot, so it's fine. Okay. But I think as long as you understand this part's just a matter of understanding the definition, so that's not a big deal. We'll get there. Okay? All right, so D, asymptotes, none. What are we kind of, what's the key thing we're looking at? Did I spell it right? Yeah. Like, what's the automatic there's no asymptotes here? Yeah, there's no bottom. There's no things that we can't have. Okay, I don't see any fractions. I don't have any 0 on the bottoms. Yeah, exactly. I don't have a top growing faster than the bottom. nothing for horizontal asymptotes, so all that stuff's good. So this guy's going to be relatively easier to graph because of that. E, intervals of increasing and decreasing. So I need my y prime, 15x4 minus 15x squared. It's convenient. So I gotta get my critical values. Okay, so my critical values are 0, 1, and -1. Okay, and I'm going to go into the chart here at the bottom. So I'm going to do x less than -1. And then I'm going to do so that's where we're at in terms of the chart there, just kind of our plus minus chart essentially. Okay, so if I do something less than -1, that's squared, that's going to be positive. Less than -1, that's going to be negative and negative. Okay with that? So plus minus minus means a plus, so that means we are positive here for increasing. So we're increasing from a negative infinity to -1. Okay, do between 0 and -1. Okay, which we would try like -1/2. That's still positive. That's going to be positive, negative, negative. So we're decreasing there between 0 and -1. Between 0 and 1, we'll try 1/2. As you can see, this is always positive. Okay, that's positive. That's negative. Okay. So still decreasing. And bigger than 1, try 2. Positive, positive, positive. All right, so our changes happened here and here. So increase to decrease, that would be a max. Decrease to increase is a min. So we're looking at max and min at those positions. So really quickly, before I change the page here, we'll just do the max min right here. So max, we know is going to be at, where's that happen at? -1? The min happens at 1. So I'll plug those in quickly. So that's going to be a -3 plus 5, going to be 2. And the min, 1, 3 minus 5 is -2. -1, 2, and 1, -2 is our max and mins. So that's F as well. We just did part F. Okay, and G, we're going to do concavity now. We'll go to the next page for that. Is everybody good? A through F. Okay, cool. All right, so we got G. So for G, we need our second derivative. So refresh, go back here. We were here. This was y prime. So another derivative. 60x3 minus 30x. Okay, so that means I can take a 30 out and an x. Okay, so my critical points in my second derivative have 0. We have plus or minus square root 1/2. So with those three values. If the chart is overdoing it for you, you don't have to do a chart. If you're okay just testing in there and seeing what's happening, that's totally fine. It's more of an organizational tool. So I'm just going to stick with it for now, but you don't have to do that every time. Okay, and then we want to test CU concave up, CD concave down. Okay, so we plug those in, so try -2. It's going to be negative, so this would be negative, this would be positive, negative. So it's concave down to start. Between those two, it's going to be really small. Square root a1/2. So maybe like -1/4 or so. So it'd be negative, and I think still negative is the point. Yeah, that's why. And that makes positive, concave up. Try 1/4, positive, negative, negative. And bigger than square root 1/2, so 5, positive, positive, positive. Okay, so there's our intervals of concave down and concave up. So our intervals would be concave down from -infinity to -√1/2 with 0 to √1/2. Concave up would be from 0, nope, oh, too big. 0 to, let's do it again. Okay. It's this one right there. That's what I want. There's our intervals. Okay, so now basic information, let's plot everything we have. So we'll kind of go back to here. I'll kind of flip back and forth. Let me try to draw a decent graph here. All right, so let's see here. So let's go ahead and plot. We'll start with the basics here. Let's do our intercepts first. Let's put a dot at 0, 0, and then our x-intercepts. So 0, 0. Let's use a different color here. Okay, our other intercepts were 5√3, so that's going to be a little bit bigger than 1. So here and here roughly. For our that's the plus or minus √5/3. Okay. We kind of have idea of symmetry. There's not much I can do with that. It's just more of just for helping with our image. Asymptotes, there's none. So then we know it increases. Or what was our y-intercept? That was 0. Okay, so we know it increases from -infinity to -1. So we know we're increasing up through here. Okay, and we also know it's concave up for most of that portion. So we need to kind of looks concave up, kind of like this. And then it turns over. What's our, we need to put our max or min. What's our max or min values there? Our max and min were -1, 2, which is perfect, so I'm like right there. Okay, and then we had our min was 1, -2. Okay, so it's concave up, increasing here, and then we start changing from there to decreasing. And it kind of has a point of inflection here about the root, the -√1/2. So that kind of twists kind of right in this region here too. So we're kind of concave up, it's still concave up, and then we're going to kind of fold down. And then it does it again just on the other side to back to up. So maybe if I do kind of right here is the point of inflection, and this is the other point of inflection. And then this kind of turns back to concave up, like so. Okay, and then it's just going to go that way. So our points of inflection, there. Oh, and 0 was 1 as well. So those 3 spots are your points of inflection. So let's just kind of go through that. It's kind of harder to draw, but this is concave up. And mostly in terms of your tests and whatnot, when you're drawing these, I'm looking at the work that you have them, not if it's perfectly cupped or not. So don't worry about that, okay? Okay, so concave up, still concave up, then it turns to concave down, then back to concave up. Okay, concave down, yeah, and then up, right, and up, back up. And so that's what the image looks like. You can do it, mine's a little bit wider in my notes, but that's what we're looking for. Okay, all right, so pause the video. I actually think we'll just stop the video so it'll be a really long one. So I'm just going to